Requirements for a probability distribution. Every probability distribution must satisfy these three requirements. There is a numerical random variable X. We don't want categories. We don't want to say grapes. We have to have a number. This means the sum. This is a sigma. And if I say I want to sum all these probabilities, 1/10 plus 1/10 plus 1/10, 10 times, for that example, the sum of P of X is equal to 1/10 plus 1/10 plus, and there's 10 of these. We add all these up, is the same as saying 10 times 1/10, which equals 1. There we have number 2. The sum of all the probabilities has to equal 1. But sums such as 0.999 or 1.001 are acceptable because they can result from a rounding error. All probabilities are between 0 and 1 for every individual value of the random variable. And whenever I have a decimal number, 0.37, that's my probability. To change that to a percentage, I have to multiply by 100. If my probability is 0.37, I multiply by 100. It's the same as moving my decimal place 2 places to the right. Multiply 0.37 times 10, and you get 3.7. By another 10, which is 10 times 10, you get 37. So 0.37 as my probability is the same as 37%. Why do I have to be between 0 and 1? Because 0 is the same as 0%, which means it's impossible for it to happen. So I can't have negative probabilities. And 1 times 100 is 100%. Let's say I have one coin and there's heads on both sides. What's the probability of getting a heads? 1. What's the percentage? 100%, because both sides have heads. Everything between 0 and 1 is really the same thing as between 0 and 100%. Let's look at this example. Consider tossing 2 coins with the following random variable. X equals the number of heads when 2 coins are tossed. Let's make our sample space. It could be heads, heads. It could be heads, tails. It could be tails, heads. Or it could be tails, tails. And that's the only possibility. X is the number of heads when 2 coins are tossed. If I want 0 heads, there's only one of those, tails, tails. Remember, the probability of 0 heads is equal to the number of successes over the total. Or I think I've called it the part over the whole before. I only have 1 success. I have 4 total possibilities in my sample space. 1 divided by 4 is 25%. The probability of getting 1 head, 1 head, 1 head. That's going to equal 2 out of 4, which is 1/2, which is equal to 0.5, 0.25. Lastly, the probability of 2 heads equals, it's 1 out of 4, which is equal to 0.25. The random variable X in the table is a discrete random variable. It's very countable. I only have 3 possibilities. It's finite. It does satisfy all the requirements of being a finite value. 2 coins tossed, the total number of heads can be 0, 1, or 2. And the table that we had before is a probability distribution because it gives the probability for each value of the random variable x, and it satisfies the three requirements listed earlier. The three requirements were, it's numerical. Yes, the random variable x is numerical. It was 0, 1, or 2. When I sum up all the probabilities, it was 1, and the probability of each event is between 0 and 1. This is x. These are my values, and they are numeric. If I add up 0.25 plus 0.5 plus 0.25, I get 1, which is a requirement. That's number 2. And every probability for each individual event is between 0 and 1, and that's true as well. Here's a histogram. This is a graph of the probability distribution of that table. 0, my probability is 0.25. 1, my probability is 0.5. And 2, my probability is 0.25. We have a graph in a table. Here's the formula. A probability distribution can also be in the form of a formula. Factorial is the exclamation point. What factorial means is x factorial is equal to x times x minus 1 times x minus 2. And it's going to go all the way down to times 2 times 1. For example, if I said 5 factorial, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. This exclamation point is called factorial. One more thing, 0 factorial equals 1. I'm going to use the formula and show you how we can get the table. P of 0. If I want the probability of 0 heads, it's equal to 1 over 2 times 2 minus 0 factorial times 0 factorial, which is equal to 1 over 2 times 2 factorial. 2 factorial is 2 times 1. 2 times 1 is 2. And then 0 factorial is 1. This is 1/4. The probability of 1 head would equal 1 over 2 times 2 minus 1 factorial times 1 factorial, which is equal to 1 over 2 times, and then 2 minus 1 is 1. 1 factorial times 1 factorial. This is equal to 1 over 2. There's my 1/4, 1/2. And if I ask for the probability that we have 2 heads, we would have 1 over 2 times 2 minus 2 factorial times 2 factorial, which is equal to 1 over 2 times 0 factorial times 2 factorial. That's equal to 1 over 2 times 0 factorial is 1, and 2 factorial is 2 times 1, which is really the same as, this is 1/4. Now we have probability of 0 heads is 1/4, 1 head is 1/2, 2 heads is 1/4, which is exactly the same as my numbers here, 0, 1, 2. There's our 3 different ways we could find it.